Okay, here we shall see about a new topic of this chapter 4, and that is cyclotron. So before we understand about cyclotron, let me just remind you about, you know, in nuclear physics. So I hope you have done this nuclear physics that we always required a high energy particle, to run out for many experimental purposes. Okay. So now the question is, how do we obtain a high energy particle? Like, how will you give a high energy to, deuteron, to the alpha particle, or to the proton, etc.? So that question was discovered by E.O. Lawrence and M.S. Livingstone in the year 1934. These two scientists, they they discovered one device and they called that device as a cyclotron. So cyclotrons, according to them, it is like a device which is used to accelerate the charged particle to a very large energy. Okay. Now let us look at the principle of cyclotron. The principle of cyclotron says that when a charged particle is entering in a region where both electric and magnetic field exists, then that charged particle, right, will perform a circular path. And this circular path, right, in this circular path, the time period and the frequency of the moving charged particle, it is independent of the radius and the velocity of the path. So this is the principle of cyclotron. Okay. Now, without wasting our time, we will discuss about the construction and the working of a cyclotron. Construction of a cyclotron. So, this cyclotron, the construction of a cyclotron, right? It can be uh, looking at this, it can be understood by looking at this figure. So, in this figure, right, this cyclotron is consists of two small hollow metallic discs. Okay, this is like a D structure, so we call them as Ds. So these are the two hollow metallic Ds, and these two Ds, they are mounted in vacuum chamber between the pole pieces of a magnet. That means these two Ds, they are placed perpendicular to the magnetic field, and this magnetic field, it is produced by two pole pieces, north pole and south pole. So we know the magnetic field is generated, from north pole to south pole in this way. So this magnetic field, it is perpendicular to the plane of the Ds. Okay. And next, the Ds are connected to a source of an alternating voltage. Now these two Ds, D1 and D2, they are connected to this alternating source. So this alternating source, it will produce an electric field inside the Ds. Okay, all right. So we will discuss better for that in the, in the higher after some times. Okay. Now the charged particle, which I'm going to accelerate its energy, it is injected between the two Ds. Let's say at this point. And this charged particle, let's say plus q. Now this charge, it is moving with a velocity v perpendicular to the directions of the magnetic field. Which means if the magnetic field is pointing down, then this charged particle, right, it is moving initially perpendicular to the field. Okay. Now The next part is this charged particle, as they enter the D's, they will gain energy. And as they gain energy, a time will come when the energy of this charged particle it is high enough, then this charged particle will leave this D through this window and it will hit the target. So this is the constructions of a cyclotron. Okay, after the construction, now we will see about the working of a cyclotron. So how does this cyclotron works? Okay, suppose I consider a charge, a positive ion, like a charge plus Q. It is injected at this point, which is between the two D's. Now this charge, okay, being positive, it will move towards D2 or D1 depending upon the polarity of the two D's. Okay, now suppose at first, let's say the D2 it is at negative potential and this D1 is at positive potential. Now because D2 is positive, so then this charge plus Q will be moving towards D2 with a velocity v. And as it enters the D number 2, then this charged particle will gain some energy, right? And similarly, because there is a magnetic field which is acting perpendicular to this D, then this charged particle, it will not go straight inside the D, but as it enters, then it will move like in a semicircular path, like this part. Okay, this is so happens because of the presence of the magnetic field, because we know that a magnetic field always produces a magnetic force to a charge which is moving with a velocity perpendicular to it, and the motion of that charge, it should be in a circular form. Okay, now this charge, it is entering the field D2 and it performs a circular path inside the D2. Okay, so as this charge it is going like this, then it will come out of the D, and once the charge is coming out of the D, then this charge plus Q, it will find that this D1 now, which is previously positive, now it becomes positive, and this D2 becomes, D1 becomes negative and D2 becomes positive. Okay, because the nature of the polarity of the two D's, it changes at every half cycle of the, or we can say it changes continuously, okay, as the charge is revolving around or inside the D's. So when this charge is coming out of the D, then it finds this D1 is negative and D2 is positive, so therefore this charge, it will move towards D1, and as it moves towards D1, what will happen? It will move in a semicircular path again, but with higher orbit, which means with higher circle. So again, as the charge is entering this D1, then the charge will gain energy due to the electric field inside D1. But the part which is performing by this charge, again it will be a semicircular part. So in this way, the process will continue. After the charge is coming out of D1, then it will find this D2 negative and D1 positive. So then the charge is moving towards the negative side. That means it is going towards D2, and as it enters D2, it gains energy, and the part that will travel inside this D2, it will be again a semicircular part, but of larger radius as compared to before. Okay, now after the charge is coming out of D2, then again it finds that this is negative and this is positive. So it will move towards D1. Again, inside D1, it will move in a circular path with a higher radius. So the process, right, keeps on continue in this way. And please remember here that every time the charge enters the D, it will gain energy. And every time the charge is inside the D, it will move in a circular path. So if the process is continue in this way, then what happen? The charge will keeps on moving, circulating around the 2Ds, right till the charge become, right, it gain an enough energy that it will come out of the window and then it will hit the target. Okay, so this is the working of a cyclotron. Okay, so after this, we will see about the theory of a cyclotron. Now, for the theory, right, we will do like this. Because this charge, as it enters the D, right, then it move inside the D, whether it is D2 or D1, it move in a circular path. So that is because of the presence of the magnetic field, and that magnetic field, it exerts a magnetic force in which the directions of the magnetic force is towards the center of the circle. So because the directions of the force is towards the center, so that force, it is a centripetal force, and this centripetal force, it is actually provided by the magnetic force. Okay, suppose at any instant of time, let's say the charge is here. So when the charge is here, let's say the radius of this orbit from here to here, let's say it is small r, and the velocity of the charged particle at that time, let's say it is v. So the centripetal force, it is mv square upon r, and this centripetal force, it is equals to the magnetic force, which is qvb sine theta. Now this theta, it is the angle between v and b. So between v and b, because initially this velocity and the magnetic fields are perpendicular to each other, so theta is 90 degree, so sine 90 is 1. So when sine 90 is 1, then I'll drop this and I'll have only qvb. Okay, now this v with this square cancel. So if you find out r from here, you will get mv upon qb. So this is the radius of the circular path at any instant of time in the 2Ds. Okay. Alright. Now what is the time period? What is the time period of revolution? Now the time period, it is defined as circumference upon velocity. Or I can say this time period is equals to circumference. When I say circumference, it means it is 2 pi r. Suppose at the instance when the radius of that circular path is r, then the circumference is 2 pi r and the velocity is v. Okay. Again, I will write t is equals to 2 pi upon v. Now I will substitute r is equals to mv upon qb. Now this v down, v up cancel. So you will get t is equals to 2 pi m upon qb. So this is the time period of revolution. Alright. So similarly, once you know the time period, then you will find, right, the frequency of revolution. And as you know, the frequency is defined as the reciprocals of the time period, which means 1 upon t. Or this frequency f is equals to, if you take the reciprocals of time, you will get qb up and 2 pi m down. This is my equation number 2. Okay. Now looking at these two, equation number 1 and equation 2. In equation 1 and equation 2, you will find there is no r and there is no v. No r, no v. So this means that the time period of revolution of the charged particle is independent of the radius and the velocity of the charged particle. Similarly, the frequency is independent of the radius and the the velocity of the charged particle. So this is actually the principle of a cyclotron, which states that the time period of revolutions of the cyclotron or of a charged particle is independent of the radius and the velocity of the charged particle. Okay, alright. Now, after this, we shall see about the maximum kinetic energy of the charged particle moving in a cyclotron. Okay, so maximum kinetic energy. All right. Now, suppose that this charge here, it is going around a circle in this way. It performs like a helical path, and as it moves in this way, then this charged particle, right, it gained energy every time. When it enters the D, it gain energy. When it enters here, again it gain extra energy. When it goes there, again it gain extra energy. So right in this way, the charged particle gains energy as it enters the D. So let us say that this energy, let's say it become maximum when the radius, let's say the last circle here, let's say this is the last circle. Okay, let's say this charged particle, right, it gains a maximum energy when it reaches this circle, and let's say the radius of this circle is r0, and the velocity of the charged particle in this circle, let's say it is v0. So in that case, again, if you apply the previous concept where the centripetal force mv square upon r is equals to qvb, which is the magnetic force. Now, but for this maximum radius, for the maximum radius, r is r0, v is v0. So instead of v, I'll write v0, okay, in this way. So this with this cancel. So from here, we will find out v0 is equals to qb, okay, r0 upon m. So this is the maximum velocity which will acquired by the positive ion, right, in a cyclotron. Okay, so if this is my maximum velocity, then what is the maximum kinetic energy for the charged particle? The maximum kinetic energy, let me write as Ke max. So this maximum kinetic energy, because we know the expressions of maximum kinetic energy is half mv square. But for maximum kinetic energy, the radius of the circular orbit should be r0, and the velocity is v0. So instead of v, I'll write v0, which means this maximum kinetic energy, it is equals to, instead of v0, now I'll write q b r0 upon m. Now this m with this m cancel. So the maximum kinetic energy of the charged particle inside the cyclotron, okay, it is equals to half q br naught, right? Sorry, I think I made a mistake because I missed out the square here, so I should write a square. Sorry for the mistake. So if you write a square, then you will get this as half, okay, this is m q square b square r0 square upon m square. Now the square with this m cancels, we will get half q square b square r0 square upon m. So this is the expressions of the maximum kinetic energy of a charged particle moving in a cyclotron.